Hello. We will talk now about a different equation that has to do with milliequivalents of KCl, and we'll visualize the math on this one as well, because kind of like with dextrose, if you've never had these things in your hand, it's hard to visualize where are these numbers coming from and why do I care. So let's read the question. A pet needs 17 milliequivalents of KCl per liter of 9% NaCl or sodium chloride. The bag of fluids has 750 mils left. KCl is 40 milliequivalents in 10 mils. How much KCl needs to be added to the 9% sodium chloride? Okay. So what are they saying? They are saying that 17 milliequivalents of KCl is this guy. I'm going to go to my shelf. My doctor just said 17 milliequivalents added into their bag, 17 milliequivalents per liter needs to be added into this patient's bag. And I go, great. I go to my shelf. I find my KCl, my potassium chloride. And right there you can see it's 40 milliequivalents. Okay, got that. So I grabbed the right thing. And now the rest of it is asking, how much do I draw out of this bottle and add into my bag of fluids to take something that is, again, heavily concentrated and dilute it out. Dilute it out. We would never give potassium chloride straight up from the bottle into a patient because it will stop the heart. Potassium chloride can and will stop a patient's heart when given too quickly or in too high of a volume. That's why it must be diluted out into the patient's fluids. All right? So that's why we're doing this, because we can never just draw this up like we would Serenia. We drop a bunch of Serenia, we give it IV, and it works. We drop a bunch of ampicillin, and we give it as IV slow push, and it works. Not with KCl. We would never do that. So this question is asking you to dilute the heavy concentration into something less. All right? Now, this question involves the pet, but not the pet's weight. And why do I say that? Because if there is this question is also one of those, kind of like the dextrose, where if they put in a pet's weight, they're trying to confuse you. All right? This is saying, how much of this dude do I need to add into some fluids to make a concentration that is different than the bottle? None of that has to do with the patient's weight. This, like dextrose, has everything to do with the blood work that came back. The doctor read it and they said, okay, according to the blood work, the potassium chloride is so low, we have to beef it up in the fluids. For our part of this, it has nothing to do with weight. So if they put the weight in there, it's meant to confuse you. You ignore it. Okay? The question also did not ask how many milliequivalents per kg or how many milliequivalents per pound. It says milliequivalents per liter. That should be your trigger. If it's milliequivalents per liter, then your math has to do with 1,000 mils or 800 mils or 12 mils or something like that. But liter is not weight, correct? We are not weighing the patient in this question. It asks you milliequivalents per liter. So that's pertaining to the patient's bag of fluids, not the patient's weight. So a lot of people say, well, this sounds very much like C1V1, C2V2. Agreed. Why is this not C1V1, C2V2? Because in the last one I said concentration can be a percent. Concentration can be mig per mil. Concentration can be milliequivalents per mil. Gosh, that is true. That is true. So the concentration listed in this question is 40 milliequivalents in 10 mils or 4 milliequivalents per mil. Okay, so at some point we have to do that math and get down to this smaller number. How many per mil? Okay. However, the reason it's different, there is no second concentration that is lesser. So if I was being asked, if the doctor said I need 0.13 milliequivalents per mil per liter, that would be different than just saying 17 milliequivalents per liter. All right? They're asking for 17 milliequivalents, full stop. But a concentration would be different. Milliequivalents per mil, mig per mil, percent. So there's nothing in that question asking for a second concentration. So if you don't have two concentrations in your question, it is not C1V1, C2V2. All right? If there are not 2% or two concentrations, if you will, being asked for, then typically, and I don't think this is going to change now in 2026, the VTNE is not asking for a C1V1, C2V2. Okay? So, how do we approach this question? What can we do? Let's imagine this. Can I just straight up draw up 17 milliequivalents of KCl from a bottle? Yes, I can. I can drop 17 milliequivalents of KCl from this bottle. So like I said, if it said something about 40 milliequivalents per 10 mil, we have to get it down to its lowest number, which is 4 milliequivalents per mil, and then we can math that out. We know this. We can take 17 milliequivalents divided by 4, and we're going to get 4.25 mil. I can actually draw that up. That is very different than the C1C2, you know what I'm saying, the dextrose question, where it said, I want 7% dextrose in my fluids. But I don't know how to draw up percent. It's a concentration. That's why we're doing that kind of math on that one. This one is saying 17 milliequivalents in 1,000 mils. Got it. I can draw that up because 17 milliequivalents in a 4 milliequivalent per mil bottle is mathable. I can math that out. Just like if somebody said, I need 2 mg of hydromorphone for a dog, and hydromorphone happens to be 2 mg per mil. Fabulous. That is 1 mil I need for that dog. That is the same type of thing they're asking for. Milliequivalent per mil, or mg per mil, or units per mil. Those are all concentrations. So you can take that part of your question divided by this, right? Milliequivalents disappear when you're dividing things, and it leaves you with mils, and you get an answer. So that's a way to visualize this. Can I just draw this up right away? Well, in the dextrose question, I can't draw up 7%. I can't draw up a concentration. I can draw up mils. So we can do that. However, the rest of the question is a little bit different, isn't it? We only have 750 mils left in our NaCl bag. So let's visualize that. The question states that if I only have 750 mils left, that means when the doctor said, hey, I need 17 milliequivalents of KCl per liter in that animal's bag of fluids, you walked over to that animal. You gave the bag a little shake and you said, yep, 750 mils is left in this bag. My doctor said it has to be per liter though, so I know I have to do some mathing to figure out 17 milliequivalents per liter, but in a 750 that's left. That's the math we're trying to get to. All right? So when a problem is worded like this, in that we have a partial bag of IV fluids left, then we have to figure out the answer for a full bag as normal. We'll do that part first, and then we set up a proportion. Okay? A proportion is when one side of your equation has to be the same as the other side. when we get done with the math. So the first part will be, if we have 17, as you can see here, 17 milliequivalents of, into 1,000 cc's of NaCl, that has to be exactly the same as, again, it's an X MEQs. We don't know how much we're going to drop yet, but we do know volume. We know volume. 750 is what's left in my bag of NaCl. So this first part is set up exactly as you would normally. We're figuring out the answer for a full bag as normal. So you set up the first part as you would normally to get a correct answer. But like I said, this is now a proportion, meaning if 1,000 mils has 17, then 750 mils would have how much? How much MEQs? Okay. When you cross multiply, that's how you figure out how to figure out a proportion equation. You're going to figure out the actual numbers that exist first. Meaning, I have 750 here, and if I cross multiply that with this guy up here, 17, okay, 750 times 17, I'm going to get 12,750. All right? I wanted to do that first because, as you can see over here, I have an X. Well, X doesn't really help me multiply and get an answer, so I'll do that part second. X times 1,000, well, that just gets me 1,000X. That's all it gets. So if I take my 12,750 divided by what's on the bottom of my equation now, 1,000. Oh, 1,000, there you go. Now I get 12.75 milliequivalents. I have figured out my X milliequivalents. Now a lot of people have gone through this math and this is where they stop because they're so they're so tired. They go, oh my God, that was a lot. And it is, but don't forget, we have figured this out in milliequivalents, which is a unit of measurement, which is not the same as mil or cc, right? I can draw up mil, I can draw up cc, I cannot draw up milliequivalent, all right? So that means we just go back to the algebra that we've had. If I know it's 12.75 milliequivalents, I can divide that by concentration. 4 milliequivalents per mil divided by 4 would get us 3.1875 cc's. And here we run into a bit of an interesting conundrum. And this is kind of off the math topic quite a bit, but 3.1875 is not something we can draw up. So is it hospital protocol to just draw up the whole number? Or is it hospital protocol to round to the nearest tenth? And that would be seen as correct. So now it would be 3.2 cc's. That is a question you need to ask your hospital and decide what is correct. Because like I said before, KCl is very potent. If we give it in too big of a concentration or too quickly, we will kill our patient. So this is actually a very valid question when it comes to math, where in other things I've said, it doesn't matter. Go with your heart. Feel it out with your gut. KCl is dangerous. One can argue that all drugs are dangerous, but KCl is one that will literally stop the heart. Anyway, that's not part of the math, I know, but if I didn't put a PSA in there, I would be a bad person. So this is how we get all the way to the end of that question. All right? And this one is just going to kind of be annoyingly hard because of how many steps there are. I know plenty of people that if it says, the question actually says up here, it says, or if my doctor comes to me and says 17 milliequivalents of KCl per liter, and I only have 300 or 200 mils left in my bag of fluids, I know plenty of people who would say, I'm going to throw away that bag of fluids and just make a new one. Because trying to figure it out when you're tired and you're on the floor and you've been overworked, I get that. But That's reality. That's real life. You get away with that. In this question on the VTNE, you don't get away with that. You have to know the math. It is frustrating, and you just do have to keep practicing and practicing, but you will get there. Don't worry about it. Thank you.